In this video, we will check how to solve a problem on projectile motion. A soccer player kicked the ball from the ground level at an angle of 30 degrees from the horizontal, which we can see in the picture, with a velocity of 43 meters per second, and we are assuming the air resistance is negligible. So this question is having more than one part. We will do it part by part. First part is asking you, what height would the ball reach? So we need to first figure out that this height is going to be in the vertical axis. That means it's delta y, and we are going to focus on the y component. Now the y component, from the diagram we can see that it is going to be v sine theta. The initial velocity in the y direction will be v sine theta. So we can write 43 sine 30 degrees, that is equal to 21.5. Now the velocity at the maximum height is going to be 0. To be specific, the vertical velocity at the maximum height is going to be 0. The horizontal velocity will remain constant throughout, but we are focusing on the vertical components. The vertical component at the maximum height will be equal to 0. Now we want to list out the equations of motion. We have got three equations of motion here. Vf equal to Vi plus At, delta y equal to Vit plus half At square, Vf square equal to Vi square plus 2a delta y. Now according to what we have got Vy initial, Vy final, and we want to find out delta y. That means the last equation is going to help us. So we'll rewrite that and substitute the values, and then use a mathematical equation or calculator and find out the value for y. Okay, so I'm just going to look at the final value, which is going to be 23.1 meter. So you can go step by step through the equation, rearrange the equation and get the value for delta y. Now in the second part, it's asking us what would be the flight time for the soccer ball. So it's the same diagram, same information as it was given to us in the equation. The time of flight means the total time in the air. That means it's the time for going up plus the time for going down. So we'll find out the time for going up first. So we know that initial vertical velocity was 21.5. The final velocity at the maximum height is equal to 0. Again, focus, we are talking about vertical velocity, and that's why it's changing. And we'll find what's the time required to go up. And from the equations which we have, three equations, we will use the first equation to find the time, substitute the values and rearrange to get the time as 2.15 seconds. Now that's the same time for going down as well, so we can just add it up and we get it as 4.3 seconds. Now the last part is asking us what is the range of the soccer ball. Now range means the horizontal distance. Okay, that means we are going to focus on the horizontal. So till now we are focusing on the vertical, but now we are going to focus on the horizontal. So in the horizontal there is no acceleration, so we'll use a simple formula: distance is equal to speed multiplied by time. The speed here will be the horizontal velocity, Vxi, multiplied by time. We already got the time, which is the time of flight, so we'll substitute that for time, which is equal to 4.3. Now the thing which I want you to focus here is Vxi. You can see that it is 43 cosine 30, which is the x component of the initial velocity 43. Okay, so we get that as 160.1 meter, and that's how